All right, welcome back. This is part 3 of lesson 6.1. So now we're going to start looking at some example problems, some real applications of the geometric sequences. So our first example says a ball is dropped from a height of 144 inches. Its height on the first bounce is 72 inches. On the second and third bounces, the height of the ball is 36 inches and 18 inches, respectively. The heights form a geometric sequence. What is the height of the ball on the sixth bounce to the nearest tenth of an inch? So let's talk about what we need to do here. Okay, we're going to break it down into some steps. So step 1, we want to find R. We want to find that ratio. And if we look at this, we know the first bounce is 72 inches. On the second bounce, it's 36. So that means we can take 36 divided by 72. That equals 1/2. So that is our ratio. On each successive bounce, it gets cut in half. That's step 1. Step 2, let's label some things that we know. For example, we know f of 1. The first bounce, f of 1, is 72 inches. We know f of 2 on the second bounce. It's at 36 inches, right? F of 3, we know that that is 18 inches. Or we can also say it's 72 times 1/2 to the 3 minus 1 power. Because if you think about that, if I take 3 minus 1, that's 2. 2 times 1/2 is 1/4. And 1/4 times 72 is going to give us 18 inches, because 18 is 1/4 of 72. So that works quite well. And we could continue, writing this out. We could do f of 4. We know that f of 4, well, that would half this, which would be 9 inches. We can keep going in those respects. So, step 3, let's write our function. F of n is equal to 72 inches, because we know that's always our starting position, times 1/2 to the n minus 1. And that n is whatever position we happen to be in. Now we are set up to where we can actually solve this problem. On the sixth bounce, so f of 6, what will f of 6 equal? It's going to equal 72 times 1/2 times 6 minus 1. If we do that, we've got 72 times 1/2 to the 5th power, which means we've got 72 times, if we take 1/2 to the 5th power, we get 0.03125. And then if I multiply 72 by that, that's going to give me f of 6, which equals about 2.3 inches. And so that's where it'll be after the sixth bounce, which makes sense. We said on the third it was at 18. The fourth bounce, it would be at 9. The fifth bounce, it'd be at 4.5, or roughly about 4.6. So we're going to be at about 2.3 on that sixth bounce. All right, another example. It says a ball is dropped from a height of 8 meters. The table shows the height of each bounce. The heights form a geometric sequence. How high does the ball bounce on the fourth bounce? Round your answer to the nearest meter. Again, we can take one of these, divide by the one before it. So I'm going to take 4.5 to divide by 6. That's going to equal roughly 0.75, and that is our R value. That is our ratio. So we can set up a function, f of n equals 6. Why did I choose 6? I chose 6 because it is the first position, times our ratio, 0.75 to the n minus 1 power. So now I want to find the fourth bounce. That's just f of 4. It's going to equal 6 times 0.75 times 4 minus 1. F of 4, if we do the calculation, it's going to equal 2.5 meters. Okay, so pretty useful way to use geometric sequences.